Hello everyone, I'm Fei from the Institute of Computing Technology, Chinese Academy of Sciences. I will give you the talk, AIBench macro and sensitive benchmarks. First, I will briefly introduce AIBench macro. As we know, AIBench marking have many challenges for simulators. For example, training an entire session is prohibitively costly, but we need training an entire session to compare the different computer systems, and the real world workloads are too large for simulators, and the real world applications are not portable across different systems and architectures because there is complexity software frameworks. We select basic AI operators and widely used hotspot kernel functions from AIBench training and AIBench inference as macro benchmarks, and we also provide different input sets to cover broad design spaces. Here are 22 macro benchmarks we provided. They are convolution, fully connected, ReLU, sigmod, 10H, max polling, average polling, cosine norm, batch norm, dropout, element with multiply, softmax, and we also plan to add more AI operators like RNN operations like RSTM and attention. For last, then I will give you a brief introduction of 20 macro benchmarks. First is convolution. Convolution is widely used in many working tasks, and we provide image data set include CIFAR and ImageLight, and we also provide TensorFlow, Cafe2, PyTorch, and pthread or pthread implementation. Fully connected layer have connections to all neurons in the previous layer. It is a matrix multiplication followed by a bias offset. We also provide input data set and different implementations. That's the ReLU is a famous activation function, and is defined as a positive part of its argument. Sigmod is another famous activation functions. 10H is also an activation function. Max polling divides the input image into a set of long overlapping rectangles, and the max polling is a linear downsampling, and outputs the maximum for each sub rectangle. Average polling is also a linear downsample method. It inputs the input image into a set of long overlapping rectangles and outputs the average value for each sub-rectangle. The cosine normalization is as this figure. This is a batch normalization. Dropout is a regularization technology for reducing overfitting in neural networks. It is an area used for technology. Element-wise multiply is a binary operation that takes two matrices of the same dimensions and produces another matrix of the same dimension. Each element I, j is a product of elements I, j of the original two matrices. Softmax is a function that takes as input a vector of k real numbers and normalize it into a probability distribution consisting of k probabilities proportional to the exposure of the input numbers. Thus, I will introduce AIBench synthetic. AIBench real-world workloads have limited workload characterizations because the AI has many workloads, and we cannot cover every AI models, and the exciting is the exact AI benchmarkings, AI benchmarks like MPro and AIBench, that use real-world workloads as benchmarks. They has short shelf life because state-of-the-art AI models evolve very fast, while adding or updating workloads are every time consuming. Also, the real-world workload has a fixed program size, so it cannot not have the good scalability. Our synthetic benchmarks is to resolve those challenges. Or we construct a design space and represent we select representative building blocks from AIBench training, include fully connected layers, a residual block, and other famous building blocks, and we also construct any other parameters like dips, networks dips, width, and input size, stride, and padding size. We also train the generated models to convergence to reflect the learning dynamics, which paradigm cannot reflect. For more details about AIBench Macro and AIBench Synthetic, welcome to visit our homepage, Bench Console and Bench Console AIBench.